İndi isə icazə versəz, növbəti çıxış üçün Professor Kaisleri səhnəyə dəvət edəcəm. Professor, thank you very much for accepting our invitation, and the floor is yours, please.
That's sort of what we're going to talk about in 25 minutes, I hope. Okay, so let's see if I can get this thing to work here. There we go. Okay, who am I? I've been an adjunct professor of engineering at GW for 46 years, as well as working in industry and the US government for all that time. I taught 35 different courses there. Including software paradigms, software engineering, etc. I'm semi-retired as of 2018, so I just still continue to teach, write books, and write papers, and help run conferences out in Hawaii, which is a nice place to go in January if you have ever been to the eastern US, okay? So I was a DARPA Strategic Computing Program Manager way back when. If you don't know what DARPA is, it's the Advanced Research Projects Agency for the US government. It is the premier research organization in the United States, okay? And then I was Director of System Architecture and Technical Advisor for the Sergeant at Arms of the United States, and also acted like his CTO. Let's see if this will work. Oh, there it goes. Okay, so what are we going to talk about? Let me move this out here so I can look at the slide. Okay, so there's lots of research in software engineering, okay? Tons of papers. Look at IEEE transactions on software engineering, ACM transactions on software engineering notes from SIGPLAN, which is an ACM organization. The problem is we've had limited progress in solving the underlying problem. The underlying problem is, how do we build good software? Okay, it's robust, validated, verified, has good performance, and it solves the problem the customer or the client wants. Okay? And so there's no unified, coherent model for software engineering. The papers, the journals I just mentioned, have lots of papers on that. There's no breakout strategy. That is, how are we going to get to a point where we have a unified model? Because everybody has his own favorite model, and that's unfortunate. There are lots of competing methodologies. I'll mention a few of them, but there's the Agile, there's the original waterfall model that was built in 1968, and there has been a number of other different models as well that some have gotten good attention and some have just died on the vine after a few years. All right? And then I'm also going to talk about a little bit about program management at the end, because that's where the problems lie also. Second turn. Okay. Oh, it worked. Okay, good. So a couple years ago, I wrote a book, 2005, called Software Paradigms, published by John Wiley. And one of the things I mentioned was the ECHO model. The ECHO model is edit, compile, link, and execute. And the problem is each of those steps, plus a couple more, requires different programs in order to perform that step. In an editor, you have text editors, a compiler, or macro assembler.
Sir, sorry, you need to...
Oh, okay. I'll try that then. Okay. I got to be able to see the slides because they're not up there. A compiler, microassembler, a linker, and an operating system, which is the environment on which all of your programs run on. In addition, we also need debuggers, documentation, and testing frameworks. And they help us when we get the link from linker to the execution stage, okay? Because we have to not only debug the program, then we have to test it thoroughly, and then we have to also document it. And I know that's the bane of every programmer, documentation. Oh no, I don't want to write documentation, but we need documentation, and that's very important, okay? So the problem is there's no shared model or description of applications. So almost every program that we write is unique, okay? And that's a real problem. That's how we share information. Okay, so what do we need? So this is my view, okay, after 50 years. We need to have domain-based requirements in analysis and engineering. When I mean domain-based, you can read AI if you want, okay? So I snuck AI in here, right? Okay, because that's the current buzzword for everybody. And the domain knowledge helps us to do good analysis of the requirements. And I'll mention this later when we talk about project management, but most of the failures in software projects are due to poor requirements analysis. And we don't have good tools for that, okay? One of the best that was Rational Rows, which is now marketed by IBM, but others fall apart and don't fully convey what we're trying to capture as the requirements, all right? Another one we need is a good systems development languages, okay? So people have written systems in every conceivable language that's out there. Somebody even wrote an operating system in COBOL once, which was kind of amazing, if you know what COBOL is, right? And so we need domain-based systems development languages that know about the environment in which they're going to run and know about the environment or the application environment, what that problem is trying to solve, and maps the application to the environment, the execution environment. And again, when I say domain-based, I mean, under the covers, AI, okay? We need a good programmer's assistant. A couple of years ago, 30 years ago, there was some good research in that area. Rich Waters up at MIT wrote a programmer's assistant. Warren Titleman out at Xerox PARC wrote a good programmer's assistant. When I talk about a programmer's assistant, it's symbiotic. It works with the programmer to help them write code, to write software. Now, a number of people have suggested that LLMs are going to be able to write software and we're all going to be out of work. I don't believe that for one bit, because LLMs are probabilistic. There is no learning. There is no knowledge in it, all right? And so they're just putting together strings of words or strings of tokens to comprise programs. And from what I've read so far, many of the programs don't come up to the level of human creativity, which is what we need to write good programs. And then dynamically composable applications, okay? Being able to take libraries and write configuration files and say, I'm going to assemble all these libraries and build some glue code between the library modules and create a new application quickly and be able to change it quickly. And there's no capability like that today, okay? And then residential environment, which I'll come back to, well, I'll talk about it now. When I talk about a residential environment, what I mean is that all the tools and utilities and programs that I need to develop an application system are written in the programming language itself. So far right now, I only know of two, Lisp and Smalltalk. I hope you've heard, some of you have at least heard of Lisp, okay? And one of the things that I belong to is a group called interlisp.org. We resurrected Medley Interlisp after it had been archived for 20 years. And now we're restoring it and modernizing it and also bringing back alive again some of the applications that were written in it. The history of Lisp is the history of early AI, symbolic AI, okay? And so we're bringing that back because I think that we are making a big mistake by ignoring symbolic AI, okay? So a residential environment says, I don't have to jump out to those other programs that I talked about. I don't have to go to an editor and then switch over to a compiler and switch over to a linker, then switch over to a debugger. Each one has its own parameters, its own syntax, and its own semantics. I can do it all within an integrated environment, and that's what Interlisp and Smalltalk, and almost to a certain extent NetBeans offers you. I don't know about IntelliJ, I don't know about Eclipse, but NetBeans is a pretty good example, but it's missing some things, okay? All right. So software, I want to talk about software development program management for a minute. There's good news and there's bad news, okay? The bad news is software development projects fail, all right? And the good news is we can determine why and mitigate the consequences. That means we can, in fact, potentially recover from software project failure. And I've been involved in a couple projects where I wrote the analysis that killed them because they were in such deep trouble from a program management standpoint. One example was the Internal Revenue Service in the United States. They'd spent about several $100 million to build a document processing system, and it wasn't ready to work, and they weren't sure if it was going to work. The IRS asked the company I work for to analyze it, and we came up with a report that said kill it and start over because the current system that they built was so bad. And so basically you threw away something like several $100 million worth of effort. All right? That's a real tough problem for management in many cases to face up front. Okay? There are many ways to make software projects fail. Krigsman, in 2012, he said the worldwide cost of IT failure is about $3 trillion, okay? All right, that's 3 with 12 zeros after it, okay? It's worse now than it was in 2012, all right? And so if you read the paper for large software projects, many of them fail. Certainly the government, they fail. Many private companies will not, however, admit that their software projects fail. They just get sort of pushed under the covers. And that's an unfortunate, because we need to learn lessons from why they fail. So Capers-Jones, who's written a lot of books on software development, software project management, said that over 50% of the software projects will fail. So of all the people in the audience, if you're all working on software projects individually, half of you are going to have your project fail, most likely, okay? It's just the history of software project development, okay? So what is the solution to fixing the problem? The problem is if we can figure out before a project fails what the causes of failure are going to be, then we can recover that project, recover from the failure, and recover some of the capabilities that we've already spent effort and invested in, okay? So my colleagues and I, a guy named Will Money, who's down at the Citadel, a military college of South Carolina, and Steve Cohen, who is one of Microsoft's chief architects, wrote some papers on forensic analysis. You could think of forensic analysis of failed software projects as, if you want to, software project autopsy, okay? Because what we're trying to do is delve into the software project and find out why it failed. And there are many, many, many causes for failure, all right? So software project recovery is a methodology for determining the mitigating causes and the remedial solutions to minimize failure and recover functionality, replan schedule, minimize further losses. Eberhard Rechten, who was a director of DARPA back in the 70s, and a program manager for a large government organization out on the west coast of the USA building satellites, said there are 3 things you need: functionality, schedule, cost. And he said you can have 2, but not all 3. Something's got to give. And typically that's cost or schedule, but most often it's functionality. People give up functionality in order to build and get something implemented, all right? And so that's a real problem. How do we think about analyzing a project that appears to be behind in schedule or behind in cost or behind in functionality, determine what are the causes that are causing that failure, and then figure out what the remedial efforts are that are going to bring it back on schedule maybe, or we're never going to recover cost. That's always usually a lost cause. And bring back some of the functionality at least. And that's an important aspect of what we need to think about in program management. Steve Cohen, who I mentioned, the Microsoft chief architect, said software project recovery is a contact sport, okay? And he truly means that because for the past 30 years, that's been his job, to go off and recover failed software projects, all right? And when you get people in a room and the project is in failure mode, there's a lot of finger pointing, a lot of blame, a lot of who did what who made the bad decisions, etc., that are causing failure. And so it can get pretty bloody, it can get pretty nasty, he said, in terms of the jobs that he's been in where he's had to tell people, you're not going to get back all the way, and try to recover what you can and move forward and reschedule or replan your functionality, but you're never going to recover the cost. That's already gone, okay? And so you need to think about that when you're doing projects. So, let's see. All right. So the point I want to make is that we've got two aspects here in software engineering for the future. How do we build good tools that help us build good software? Okay, the tools we have today are adequate, but they're not helping us build good software. And so I made a couple suggestions. There are others that can be made, all right? And then we also have to think about program management. How do we run programs, or projects rather, for large applications, all right? Typically good small applications with maybe 20 people are often very successful because there's a minimal set of communication lines. If you have N people in a group that is building a software project, then you have N times N minus 1 communication links, all right? So the more you increase N, the worse your communication links get and the greater probability of software failure because people talk at cross purpose to each other. So the question is, how do we do these two elements, these two components of modern software engineering? And the challenge I have for you is, what are you going to do about it? Okay? Are you going to go out and help build these tools? Are you going to go out and learn about program management and learn how to build or how to do software recovery if necessary? Okay? Because it's a hard skill to learn. Like I say, Steve has been doing it for 30 years and had successes. Sometimes he's had failures. Sometimes he comes to the point where he just says, look, we got to cancel the project. No point in doing it further. And then the question you make is, do you start over again or you just abandon it? Okay? He said sometimes my clients abandon the idea. Okay? They don't want to start over. So I'll leave you with this thought. Remember, functionality, schedule, cost. Okay? Have two, but not all three. So when you're planning a project up front, even though you're planning the budget, even though you're planning schedule, even though you're planning the functionality, you also ought to think about which one you're going to have to give up if the project starts to fail. Okay? That's sort of the idea that I want to leave with you with. These are things that we got to think about for the future.